Section 3.1, number 34. We're given this function f of x is equal to x squared plus 10x plus 14. It's quadratic. It's positive in front of the x squared, so it's opening upwards. We're asked to find the vertex and any x-intercepts, if there are any. So it's a positive here, so it's opening up. And I do like to have a picture so that I can kind of verify as I go. So for this one, I'm going to try to use completing the square, because I'm going to use part of it. I'm going to use it once to find my zeros, if there are any, and the second time we're going to end up getting very much the same results, but we're going to use that to find our vertex. Okay? So, completing the square. So the first thing I want to do is I want to see if this is equal to 0 anywhere. So I'm going to have an x squared plus 10x plus 14. Completing the square tells us that I find my b, which is 10, take half of b, which is 5, square that, which is 25. I add that and I subtract it. The addition I'm going to keep with the x bits, because that will give us our completed square. And the negative is going to get mixed in with that other constant. Okay, so we're going to get x squared plus 10x. We're going to add my 25. We're going to subtract my 25. And then I still have my plus 14 left over. All right. So when we simplify this, this is my perfect square. This is x plus 5 squared. Right? In fact, if we FOIL this out, x times x is x squared, x times 5 is 5x, 5 times x is 5x. There's two of those. 5 plus 5 is 10. 5 times 5 is 25. So this is that thing. Minus 25 plus 14, it comes out to be minus 11. So if I'm finding my zeros, I need this thing to be equal to 0, in which case I will add 11 to both sides. It'll cancel over here, leaving us with an x plus 5 squared is equal to 11. And then I take a square root of both sides. The square root and the square will cancel, leaving us with x plus 5. The square root of 11, we have to allow for both the positive and the negative square root. Okay? And then I subtract my 5 over, leading us to my two roots. X is minus 5 plus or minus the square root of 11. Okay, so x is equal to minus 5 minus the square root of 11. Numerically, let's pop out Wolfram alpha and see what we get. All right. Minus 5 minus square root of 11. This is about negative 8.31. Negative 8.32-ish. Okay, and the positive side, canceled out one of my minus 5 plus square root of 11. This is about negative 1.68-ish. Okay? So both my axis crossings are on the negative side. So it's going to be something like negative 1.68, about negative 8.32. Okay? All right. Now, I don't want to erase all of this information, because this quadratic is the same as this expression. But this expression has the proper form that I'm looking for. Right, now, if we remembered in class, I talked about if we have f of x equals a times x minus h plus k, this is going to have a vertex of h comma k, right? Where our x value is our h, or the negative of whatever we have here, and then this k, whatever we have there. So this tells us that the vertex is minus 5 in the x, and it's going to occur down here at negative 11. So this point is going to be negative 5, negative 11. And that's going to be your vertex. Since it's an up-opening quadratic, this is going to be a minimum. And that's the important information.